Hello everyone, welcome to video number 8 of Java Fundamentals. In this video, we're going to talk about debugging and pointers. So first of all, debugging. When your program produces an output that is not the same as the output it should produce, your program has a bug. And debugging is the process of finding it and fixing it. So to show you how debugging works, I'm going to show you an example of an algorithm that has a bug and how to find it and fix it. So here's the prompt. Write a program that takes a string of zeros and ones as input, and for each group of n consecutive ones, even if n is 1, add n squared to a total that will be outputted in the end. So this might be confusing, but here's an example. So we have sample input and sample output. And for the sample input, we see that we first have a group of 4 consecutive ones. So that should add 16 to the total. And then we have a group of 3 consecutive ones, and that should add 9 to the total. And then we have 1 consecutive one, and that should add 1. And then we have 2 consecutive ones, which should add 4. So 16 plus 9 plus 1 plus 4 is equal to 30. And that's why the output for this input should be 30. Here's an algorithm for that prompt. So first we take an input and then we initialize 2 variables. So first of all, n, that keeps track of the number of consecutive ones, and total, which is what we'll be printing out at the end. And this for loop right over here, it scans through every single character of input. And then if the current character is 0, then we increase the total by n times n, which is the same as n squared. And then we reset n, we set it back to 0. Otherwise, if the current character is 1, then we increase n by 1. And then at the end, we print out total. So let's run this and give the sample input and then see what it outputs. All right, so it prints out 26, but we knew that the answer was supposed to be 30, and that's not what the program gave. So our program has a bug. And to debug it, one way you can do it is to just run through the program yourself, just like the computer would, but that would be very slow and difficult because the computer is a lot faster than you are, and you also need to remember the values of the variables at all times. So that is not a recommended method. A better method to debug will be to print out information as your code is running that can help you find where the bug is. So the problem that we have right now is that the value of total is not correct in the end. So what about we print out information every time we change total? All right, so let's print out, for every time we change total, let's print out the index A, and then the space, and then n times n. All right, so now let's run this. All right, so it gave us this information right over here. So the first time we change total, we're at index 4. That's this 0 right over here. So we've just scanned through this group of 4 consecutive ones, and that should add 16 to the count to the total, which it does. All right, and then the next time we change total is when we're at index 8. That's this 0 right over here. So we've just scanned through a group of 3 zeros, and that should add 9 to the total, which it does. And then the next time we change total is at index 10, which is this 0. So we just seen this 1 0 right over here, and that should add 1. And then after that, the total does not change anymore. And with this, you can figure out what the bug is. The bug is that we did not add this group of 2 zeros because our algorithm only changes the total when it sees a 0, but there is no 0 after this group of 2 ones right over here. So that's why our algorithm did not account for these 2 ones. All right, so now we found what the bug is. And to fix the bug, and make sure you remove this print statement because you don't want to be printing out random things. After the for loop runs, what we need to do is just increase the total by n times n. All right, now let's run this again and see what it prints. All right, now it prints out 30, which is the correct output. So this is a simple and common method to debug. And there are some other methods, but you're not going to need to know about them for this course. However, I'll give you a brief introduction to one other method to debug, and that's called breakpoints. So to use breakpoints on replit.com, you just click on the debugger tab on the left. And to add breakpoints, you click on the left side of any line number. All right. And then what breakpoints basically do is they allow you to run your code in sections, pausing after each section. And the breakpoints, they signal the start or end of a section. And what running your code in sections does is it allows you to determine which section of your code the bug is in. And that makes it much easier for you to find where the bug is. So this is a function that breakpoints serve. So that was debugging. Now we're getting into pointers. So if you remember in video number 6, I talked about if you have 2 arrays A and B and you wanted to copy the contents of A over to B, you can't just do B equals A because that will have an unintended impact. But what is that unintended impact? Well, that is what pointers tell us. So suppose you have this code right over here. What does it output? Well, let's start from the beginning. The first 2 lines, they initialize 2 arrays, A and B. And what initializing them really does is it tells A to point to this array right over here. And it tells B to point to this array right over here. And then what B equals A does is it tells B to point to whatever A is pointing to. So A was originally pointing to this array right over here. Therefore, B will also point to this array right over here. And this array at the bottom, it no longer has anything pointing to it. So Java just erases it to free up memory. And then if we get to the next line, so B0 equals 1, that changes the first element of B to 1. So this is B right over here. And notice that since A is also pointing to this array right over here, by changing B, you've also changed A. So this is the unintended impact that B equals A would have. It causes, not only does it cause the content of one array to be transferred over to the other array, it also causes them to point to the same thing. So whenever you modify one array, it will also modify the other array. And then now if you print out B0 and A0, well, that's just the first element of this array in both cases because A and B are both pointing to this array. So this will output 1 and 1. And it seems that we've just made A and B the same thing. Does that mean that A and B are the same thing for the rest of our code? Is there any way that we can possibly change them so that they're no longer the same thing? Well, yes. And we're about to get to that in this example right over here. So what does this code right over here output? Let's start from the beginning. First, we initialize 3 arrays. So A, B, and C, they're all pointing to different things. And then now we're getting into this section right over here. So first C equals B, that tells C to point to whatever B is pointing to. So that's this right over here. And notice that this array down here, it no longer has anything pointing to it, so therefore it's erased. And then the next line, B equals A, that tells B to point to whatever A is pointing to. So A is pointing to this array right over here, so therefore B will also point to this array over here. And then B equals C, that tells B to point to whatever C is pointing to. So C is pointing to this right over here, so therefore B will also point to this right over here. So notice that we originally got B and A to point to the same array, but by doing B equals C, which that will cause B to point to a different array. So now A and B are no longer pointing to the same thing. All right, and then B0 equals 1, that just changes the first element of this array to 1. And notice that since C is also pointing to this array, it will also modify C. All right, and then now we print out, so A0, B0, C0, that will print out 3, 1, and 1. So now that you know what pointers are, here's an optional exercise. Write a program that first initializes 3 arrays pointing like this, and then changes it to this. And you can make more than 3 arrays if you need. So if you want to give this problem a try, then pause the video here and keep watching for the solution. Here is the solution. So first we need to initialize 3 arrays, A, B, and C. And then we also need to initialize a 4th array. We'll call it D, and we can make it whatever we want. So I'm just going to initialize it like this. And what D serves as is a placeholder, because remember that if any of the arrays has nothing pointing to it anymore, then it will be erased. So what D does is it prevents any of these 3 arrays from being erased. So we can change A, B, and C in any order, but I'm going to change C first. So in this case, we need to do D equals C. If we don't do this, then once we change C, this array right over here will be erased. All right, and according to the diagram that you saw in the problem statement, we want C to point to what B was originally pointing to. So we do C equals B, and B should point to what A is originally pointing to. B equals A, and then A should point to what C originally was. And D is the placeholder for C, so we do A equals D. All right, and this is the solution. So the topics covered today were debugging and pointers. And normally I would encourage you to make your own programs to remember the concepts, but for this video, I'm not going to, because even if you wanted to make your own programs, it's hard to think of examples of programs that you could make with these 2 concepts. So I'll just say, try to remember these 2 concepts. It's not too much to remember, and these could be very useful in the future. And that's it for this video. And we only have 2 videos left, so I'll see you in video number 9.